Hello there, this is Lord Artorius Colbrand, and today we are going to talk about something different. Something different than usually just kind of reviewing anime and games and stuff like that. Don't get me wrong, I love that kind of stuff still, like reviewing like all that stuff, but I just decided to do this as like a bit of interesting side content. And I want to just kind of share with you guys something really cool and interesting, how to actually solve this kind of stuff. Here's why I'm making this video today. The reason why I decided to make this content and put it out there for people to watch this video is because I wanted to just be able to show everybody that I actually have a huge passion for astronomy, and I just wanted to share this information as a cool way to show everyone what I was learning in college over this fall. I wanted to just show everyone this is how you figure out how far away a star is by doing math. I actually never talked about this on the internet before enough, but for many years, I've also been literally fascinated by astronomy and aliens and other cool stuff like that. And I wanted to make this as a bit of side content on the side of reviewing games, anime, and movies. Just to show my channel also has a wide variety of content, and I have a lot of interesting things to always talk about. When people watch this video can be viewed as a way to help students in their astronomy class at college, and like what I did to help them get, through, like what I did to help them to get through learning a ton of cool stuff. Or people could just watch this for fun and also just learn about cool stuff in astronomy. Now, I do want to make this clear. I am not a professor and I am not a teacher, but I wanted to share this because this was just something that I learned that was really cool and interesting in my astronomy class over the past like few months. So before we really dive into anything, we have to really talk about, so what is a parsec? A parsec is the largest unit of distance in the universe. To know just how long one parsec is, one parsec equals 206,265 astronomical units, 3.262, well, 3 in 262 thousandths of light years, and 19 trillion 170 billion miles. This unit of distance is used to measure the distance of stars. So here's the math equation that I learned how to actually figure out how far away a star actually is. Please note that 1 arc second is 3,000 is 1/3600th of 1 degree of a degree. It's also 1/60th of an arc minute. The numbers of these parallax angles for stars are usually extremely small, so the lower the number for the angle, the higher the number of your answer on parsecs. Because doing division, this is doing division math. Anytime you're dividing a number by less than 1, it'll become more like multiplication rather than division because you're raising numbers instead of making them smaller. The only number that you can't obviously divide by is 0. And as you can see, you would do 1 over, the parallax angle of a star in arc seconds to figure out the distance in parsecs. Here's an example of this problem, just to kind of teach people how to actually do this. So Betelgeuse has a parallax angle of 0.0444 arc seconds. 0.044 arc seconds. Using your calculator, you can find out the distance in parsecs with just how far away Betelgeuse is from Earth by plugging in 1 divided by 0.044. Literally, that is it. It is that simple. The answer you would get rounded to the nearest hundredth is 22.73 parsecs away from Earth. If you wanted to get light years, you would have to multiply the distance in parsecs by 3.262 and round to the nearest hundredth. Rounded to the nearest hundredth, you would get that Betelgeuse is 74.15, 74 and 15 hundredths light years from Earth. That's how long it would take light to travel to that star. So kind of to give you an idea of how long that would also take the world's fastest built thing in order to actually reach getting there, here's how long it would actually take to get there. The world's fastest thing that we've ever built in history is known as the NASA Solar Parker Probe. It has a top speed of only 394,736 miles per hour. Doing math, that's 6,578.9 miles per minute, rounded to the nearest 10th number, and only 109.65 miles per second, rounded to the nearest hundredth. So still not even close to the speed of light. Considering how it would take light 74.15 years to get to Betelgeuse, that would mean it would take light 27,082.546 days to get there, and then 649,981.104 hours, 38,998,866.24 minutes, and around 2,339,931,974 seconds for light to reach Betelgeuse. Considering how 1 light year is around 5,879,000,000,000 miles, and how the Parker Solar Probe only travels at 394,736 miles per hour, that means if someone was able to board that thing and travel that quickly, it would still take them, if I'm doing math right, a whopping 14,893,498.44 hours, 620,562.435 days, and 1,699.054 years, rounded to the nearest thousandth, to reach 1 light year distance. Going back to how Betelgeuse is 74.15 light years away from Earth, that would mean that it would take 125,984.84 years for the Parker Solar Probe to travel and reach Betelgeuse, rounded to the nearest hundredth. That's so long in time that one can only imagine what Earth would be like then. That's fascinating. However, it does show that with the current technology that we have equipped right now, traveling to this destination would be impossible. Please let me know in the comments down below if you found this information fascinating, and I hope this video was helpful teaching how to find the distance of stars in parsecs and light years. It's actually a dream of mine that I would be able to do something with physics and astronomy one day in the future. And I just wanted to make this video showing you guys what I learned when I was in school, college, and present this to you. I believe it's possible I may be wrong with a bit of my information, so I wouldn't take every word I say for granted, but I hope this video is at least useful in teaching somebody how to use a math formula for measuring star distances. According to a source I found this information from, it states in reality that Betelgeuse is actually 427 light years away from Earth, and not what I actually found as an answer from doing math. It does raise a few eyebrows, and I completely understand, and I'm willing to take constructive criticism that I may have miscalculated something, because that's the answer that I got off of using a formula that I've used when I was in college not too long ago. let's just say at least that I found this personally fascinating learning this in college because I just absolutely love astronomy so much. Let me know if you guys think that I should make a part 2 to this video and talk about and try to mathematically solve how in reality Betelgeuse is actually probably 427 light years away from Earth. I mean, like I said, it's not what I mathematically got, but there's always a chance that I was probably wrong. I'm willing to hear how I may have gotten the wrong answer, possibly by accidentally, you know, possibly being incorrect about something. It's all part of learning, and yeah. Thank you very much for watching. Please hit that subscribe and like button for more awesome content, and thanks for watching.